Do you want to make software applications for the Raspberry Pi? By the end of this video, if you follow my instructions, you will have written and run programs in 6 different languages. I've tried to make this tutorial simple enough even for a beginner with no experience necessary. Anyone capable of plugging in and powering on a Raspberry Pi should be able to follow this. If you don't know how to do that, please take a look at my previous video about how to plug in and power on a Raspberry Pi. Welcome to my workbench. This is my second and hopefully final introduction to the Raspberry Pi. After this, my computer-related content will hopefully be about creating intelligent behavior on your computer. Eventually, I might even show you how to build a robot with feelings. But if that happens, it's several years away. So first, we need to start simply. We will be writing the simplest programs possible, so it should be easy to follow along, even if you've never programmed a computer before. Traditionally in programming, the simplest possible program is called Hello World, and all it does is display the message, Hello World. I'm going to walk through writing and running Hello World programs on the Raspberry Pi in Python, HTML, client-side JavaScript, C, C++, and Node.js. I'll also introduce the basics of Git source control, where we are going to pull down and run some more complicated programs. First, we are going to start with the most popular language for the Pi, Python. It's named after Monty Python, not the Raspberry Pi. It's included standard on the Raspberry Pi operating system, so there's no need to install anything. And you'll find a lot of help online for any kind of software questions you're going to have. It even comes with a Python code editor called Thonny. Let's start programming using the monitor and keyboard directly connected to the Raspberry Pi. We've already opened up Thonny. You can find it in the programming menu. And let's write our first program. It will simply be print, left parenthesis, quote, hello world. We'll put a little exclamation point. Let's make it exciting. Now, all we should have to do is just push the big jolly green run button, and it is run and given us our message. You're a programmer, Harry! If you want to learn how to write cooler programs than this, I highly recommend Invent Your Own Computer Games with Python, which you can read online for free. If you wanted, you could stop now and start programming, but I think it's worth taking a look at a few other languages. Next, let's talk about HTML. HTML is not a real programming language. It's more of a language used to define user interfaces. You know, the part of the application that you can actually see. It feels more like a word processing document, and it uses like little greater than and less than signs to make little marks into the document to tell the browser how to display it. Let's close Thonny and open up Geany. This is a more general purpose code editor. I like it because you can use it for anything, not just Python. Let's make an HTML document. It always starts with a doc type of HTML. Then there is an HTML tag. You can define the language as English, and we're going to put a title in. All of the tags will start with the less than and greater than, but some will have closing tags, like this. It ends with a tag that starts with a slash. Okay, let's make this a big heading. That looks pretty good. Let's save it somewhere where we can find it easily. Maybe just the home. Yeah, that'll be fine. And let's name the file HW for hello world .html. Now let's find it. Open up the file manager, go to my home directory, and there it is. I'm going to double click on it, and it should open in the default browser, which I've set to be Chromium. And there it is. See, the title tag is up here. It says Hello World in the title, and then our main heading is right here. Now, I've said HTML is not a programming language, but it does come with one. It's called JavaScript. Let's make a script element. Look at that. Geany knows that I'm in HTML. It automatically made the closing tag for me. Thank you, Geany. We're going to type in a line of JavaScript. Alert. Guess what it's going to say? Oh my God. You guessed right. Save it. And we're going to refresh. And look at that. We get a little pop-up. We've written 3 programs already, one in Python, one in HTML, and one inside of our HTML page using client-side JavaScript. Now let's go a little deeper and write a simple program in C. Writing code directly on the Raspberry Pi is simple, but sometimes you need to switch between multiple Pis, or you just like to use a nicer computer and keyboard in a more comfortable place. So writing code remotely is definitely a good option. You will need to turn this on the Pi. Go to Preferences, Raspberry Pi Configuration. Then go to Interfaces and make sure SSH is turned on. I have my MacBook Air here. To SSH into your Raspberry Pi, just open a terminal window and type in SSH, your username, the @ symbol, and the IP address of the Raspberry Pi. This is only going to work if you're on the same local network. You're not going to be able to do this from the internet for good reason. I would not. It's insecure. Enter your password, and now we are in. I am working directly on the Raspberry Pi now. Now it's time to write our first C program. Disclaimer, this is my first C program too, so be gentle. And we are going to write it from the SSH terminal. We can't use Geany from this, so we will have to use a terminal-based editor called Nano. And we will call this program HW for Hello World.c. Now we're ready. First, we're going to have to include a library to get started. And write our main function. And the only line in our main function is going to be printf hello world. And with a semicolon, close our bracket, Control X. Looks good. Now, unlike Python or HTML, we can't run this directly from the file that we created. We have to convert it into machine code first. And we use a compiler, the GNU C compiler. And we'll say its output is a file named HW. And its input is the file we just wrote. And it compiled. Now we can run it with /HW. Ooh, it worked, but it sort of put it behind there. And I spelled hello wrong. Yeah, all programs have bugs, even Hello World. Let's fix these things and go up. I'm using the up arrow just to go through my commands. Let's fix hello. And then at the end, we'll put in a \n for new line. Control X, Y, enter. Let's recompile and rerun it. That's much nicer. It's spelled correctly and it's on its own line. I'm a genius C programmer now. C generally is used for lower level stuff when you want to interface directly with hardware, which is why I never use it. Another language that comes already installed on the Raspberry Pi is called C++. It's very closely related to C. It is C with some more advanced features. Let's write a Hello World app for that. And let's go to Nano, and we'll call this HWC++. This is going to look very similar. Include, the library is called IOStream, using namespace std, semicolon, our main function, C out, less than, hello world. And we'll do the new line and end with a semicolon. Close our bracket, Control X, yes, and that looks good. All right, let's see if it'll compile. The C++ compiler is called G++. So let's run G++, output, hello world, we'll call it PP so that it doesn't write over our old one. Input, CPP is the file we just wrote. Oh, I spelled IOStream wrong. I have too many cameras to watch. Okay. Exit. Compile again. I'm a terrible programmer. Let's try that. Well, it's about time. We'll run it. ./HWCPP. What did I name this? Oh, HWPP. There we go. Finally. Oh my gosh. Debugging is just so much of programming, especially if you're a fat-fingered typist like I am. Now, we've covered all of the programming languages that I know of that come installed on the Raspberry Pi. But let's install a new one, Node.js. The easiest way to get this, in my experience, maybe not the best way, is to use apt-get. So let's type in sudo apt-get update just to make sure we have everything, has all of the most current versions. And then sudo apt-get install Node.js. And let's also install npm, which is the Node Package Manager. We're going to use that to retrieve code that we need to run our code for libraries and utilities and things like that. Wow, that took forever. All right, let's just test it. We're going to type in node-v. Should give us the correct version. Awesome. Version 18. Since we're using my fancy MacBook Air, let's use a fancy editor. The one I've been using a lot is called VS Code, developed by Microsoft. It is a cross-platform code editor. And let's make our node file. We'll do a new file, and we'll call it hw.js. Node is JavaScript, so it'll look very similar to the JavaScript that runs directly in your web browser, except this is more like Python, where you don't need a web browser. You can just run it standalone. I will make this a console log. Well, looks pretty good. I've saved it on my computer. Now we have to get it over to the Raspberry Pi. How do we do that? I am going to use SFTP, which is just SSH file transfer with a nicer UI. I'm going to use the program FileZilla, and we are going to connect. Right, this is 219 is my IP address. I already have this set up. Going to connect. Oh yeah. Excellent. Now I can transfer files back and forth to my Raspberry Pi. Let's see if I can find the file I just made. HWJS, there it is. And we'll just drag it over. Transfer successful. We'll go to our terminal. And there it is. All right, let's run it. Just type in node hw.js. And it works. We've proven that we can get code from multiple languages running on our Raspberry Pi. But we probably want to run more than just hello world. Luckily, you have access to a massive library of programs written by other coders. For better or worse, the most popular place to get other people's code today is GitHub. So let's start by pulling down some stuff I wrote. Here is GitHub, and here is the code that I'd like you to pull down onto your Raspberry Pi if you want to. I'll demonstrate how it works. Hopefully you like it. I'll put the link to this page in the description, or you can just search GitHub for it, look up behavioral logic. This is the only thing that's there right now. To pull it down, go to where it says code with the little green buttons. I usually use SSH, but let's keep it simpler and use HTTPS for now. Setting up SSH keys for GitHub is kind of a pain in the butt. I just copied this, and we are going to now clone this repository. Normally I make a repositories directory. Let's do that. So let's do mk make directory, and we'll call it repos. Now let's change to that. Now we're going to run our git command. So it is git clone, and then I'm going to paste in what I just copied from the website. Now it's there. rpi.gpio. Before we run it, we're going to need to install some dependencies. Remember that npm I had you install? Let's run it. npm install will pull down all of the code that I have mentioned in the package.json file that this program needs to run. The other thing we're going to need to do is install a program called PyGPIO. So let's use apt-get to do that. Git install PyGPIO. First I thought it was PigPio, which is kind of funny. But no, it's PyGPIO. So far, no problems. If everything worked, we should be able to run this using npm start. It's running. But what did it do? Well, let me show you. It is a network application. So copy this address, put it into the location bar of your browser, and hit enter. This is what is running. This is a simple utility that I wrote that we can use to toggle on and off the GPIO pins. Should be pretty useful. Let's see if it works. The code that you run might not look exactly like this. Like all software, this is a work in progress. Hopefully I've made improvements and it looks and works even better when you're trying it. Like, what the heck is this stuff? I don't even know. It'd be great. Maybe if you hovered over it, it would tell you or something. If we click one of these buttons, that should turn on or off the corresponding pin on the Raspberry Pi. Let's see if it actually works. I have a breadboard that is attached to the GPIO pins. If you don't have one, there is a way to do this simply that I'll show you in a minute. Along the side here is a 5-volt power source. Plug it in and plug it into an empty slot over here. Now let's take we have a blue LED. Use whatever color you like, and we're going to plug, notice the leads, there's one slightly longer and one slightly shorter lead. You're going to want to plug the longer lead into the same row as the power source and plug the shorter lead into just some other row. LEDs will only work one direction. The D stands for diode, which is a one-way resistor. So now let's add a resistor in line because these LEDs can draw a lot of current and you don't want to burn out the LED or your Raspberry Pi. Here is a 10 kilo ohm resistor. I'm going to put that in the same row as the short lead and then in an open one. Now I'm going to complete the circuit by going from the one end, and I'm going to put it in, any ground will do. Let's try this. I am an electronics genius. Let's get this set up to test my tool. Let's plug this into row 19. Good. It's not working, which is exactly what we want. Let's go over to the tool, push 19. Let's see if it works. Gonna push number 19, and it turns on. Yay! If I push a different one, it does not turn on. Let's move it over. Let's move it one over. Try 13. 13 works. Any of these should work as long as they're not grounds or one of the constant voltage pins. If you don't have a breadboard, let me show you what you can do. Get rid of this, and we are going to grab some female to female pins. These jumpers are a little socket. Now what we can do, with the help of our diagram, let's try this with an open one. It's 5. Plug in the long lead. Plug in another female to female. Oh, what is it? A cat party? Is that what it is? Are you interested? Let's plug in our resistor. You're kind of in my light, kitty. Cannot see. Seriously. This should even work, even with a cat butt on it. Okay, let's plug it in to a ground. And as you can see this, kitty? It lit up. Unplug it. Look, I'm not the one who set you there. Okay, we're going to plug this into 19. And we're going to plug this into ground. Right here. Now, there we go. See how that works? 19 to ground. Here's our circuit with a resistor in series. Nice. And thank you for your help, little guy. What a useful animal you are. If you're trying to follow along and it's not working for you, please leave a comment and I will do my best to get back to you and help you out. If I find a better way to walk people through this, I will change the README file in the repository. And if enough people are interested, I'd be happy to do a live stream and help walk you through it. If I've already done that, I'll put a link to the live stream in the description. Subscribe and ring the bell if you want to be notified for when that happens, or when I post an even cooler video, like how to program a robot with feelings. I hope this is a great start to your journey programming the Raspberry Pi. Until next time, take care of yourself and make good decisions. Juniper, are you trying to eat my brain? Absolutely not, young man. Give me those. Both of you. Just gonna steal my chair now, aren't you? You don't even care. Okay. No. Look, you've broken it. Oh my God, you have broken it.